Hello everyone, my name is COMP3132 and this is assignment 4 on overfitting in convolution neural networks. I'll use TensorFlow and Keras on the Sci4 10 dataset. The notebook covers data preparation, train and validation, and test splits. An intentionally over-parameterized baseline that overfits, at least two techniques to reduce overfitting, loss and accuracy plots, and how I pick a reasonable number of epochs. First, I set random seeds for reproducibility and input NumPy, TensorFlow, Matplotlib, Keras layers and models, L2 regularizers, and early stopping. Okay, so in the first section is data preparation and splits. So I load Sci4 10 from TF Keras datasets. Images are 32 by 32 RGB. 10 classes. I normalize pixel values to 0 to 1 by casting to float 32 and dividing by 255. Labels are one hot encoded for 10 classes. I keep the official test set untouched for final evaluation. So from the original training set, I take 20% as validation, the first slice in code, and the remaining 80% as training. So train for fitting, validation for tuning, and early stopping. Test only at the end. I'll run the cell and point out the printed shapes for train, validation, and test. So in section 2 is the baseline model designed on purpose to overfit. The architecture stacks convert 2D blocks with 64, 128, and 256 filters, max pooling, then a flattened layer and a very large dense layer with 2048 units before the softmax output. There is no dropout, no L2 or L1 or L2 weight penalty, and no data augmentation. I compile with Atom, categorical cross entropy, and accuracy. I'll scroll the summary so you can see parameter count and layer order. Then I train for 20 epochs with batch size 128 and train data and validation on the held out validation set. Training may take a while. I have already run it here. Yes, as you can see here, this. And now after of training, I evaluate on the test set and print baseline test loss and test accuracy. Finally, this helper plots training versus validation loss and accuracy across epochs. For the overfit baseline, you should see training accuracy rise, while validation accuracy lags and validation loss get worse or unstable compared to training loss. That gap is the signature of overfitting. So now let's move to the section 3. Here I apply several techniques together to reduce overfitting. First, data augmentation, random horizontal flip, small random rotation, and random zoom. This increases effective diversity without new images. So second, L2 kernel regularization on convolutional and dense layers with a small coefficient. Here 1 minus 4. Third, drop out at 0.5 after the main dense hidden layer. Fourth, early stopping on validation loss with patience for and restore best. Wait, so we keep the weight from the best validation epoch, not the last one. The regularized model uses smaller conv blocks and 256 unit ends head instead of 2048, so the classifier is less extreme than the best line. I train up to 30 epochs with the same batch size and validation data, but early stopping may finish sooner. Then I plot the regularized model curves. You should see training and validation tracks closer together than the baseline. The next figure compares baseline and regularized validation loss and validation accuracy side by side, so the improvement in our generalization is easy to see. The last cell in the section finds the epoch with best validation accuracy, prints it, and reports the first epoch where validation accuracy crosses where validation accuracy crosses 70% is an example of acceptable metric timing. If nothing compares, say, if nothing reaches 70%, the notebook says so clearly. So in conclusion, the baseline shows clear overfitting, training keeps improving while validation does not follow as well. Combining data augmentation, localization, dropout, and early stopping improves generalization and typically tests performance versus the baseline. Early stopping also gives a practical answer for how many epochs are enough. That completes assignment 4. Now data preparation splits over parameterization. So thank you for watching my assignment for presentation.